Hey guys, this is Wojtek, and today we're going to continue our props series looking at physical constraints. Now, we're also going to modify our player character a little bit to add some attack modifiers so we can easily switch between light, medium, and strong attacks. And then we're going to move on to adding these fun little punching bags. So we're going to use physical constraints to basically create a spring that our punching bag moves back and forth on, as well as we're going to introduce a little bit more freedom of motion. So we're going to modify our physical constraints so the punching bag can swing around a little bit more gracefully. And then we're going to do the exact same thing with our mannequins, just to show you how you can attach player characters or enemy characters to these physical constraints. So we saw our spring back mannequin, and there's our lovely swinging punching bag. And then we're going to use these guys in future videos for various nefarious needs. Alright guys, so let's get started. And since the majority of our lesson is going to be spent looking at the physical constraint attributes, we're not going to be doing that much C++ code, I thought, hey, let's take an opportunity to still continue developing our skills by introducing a couple of attack modifiers. What we're going to essentially do is convert our random attacks into light, medium, and strong hits. And that way we have a little bit more control over our character as well as the things we're going to be punching. So let's go ahead and kick this off by going to our project settings, input, and adding these two new attack modifiers. So our light attack modifier is going to be one of these guys, and I'm going to use the left shift key for this guy. And then we're going to add another one called a strong attack modifier. And we're going to use our left control, CTRL, there we go, for that particular attack, with our medium attack kind of being our default for our punch and our kicks. Okay, so we have our modifier keys. Now let's flip over to our C++ code, where we're actually going to implement these two key definitions. So let's hop over to our player character header. And what we're going to do is somewhere around our attack type, we're going to introduce a new enum. Let's just get that set up. And this enum is going to represent the strength of our attack. So I'm going to call this guy attack strength. And uint 8. And I'm just going to say light. And let's copy this meta definition. So this is going to be our light attack. And we're just going to copy this a few more times for our medium as well as our strong attack. Oops. And medium attack. Okay, so we've got this enum, and this is going to allow us to flip between these various modes as we actually perform our attacks. Okay, next, we need to actually be able to trigger these attack changes through our key binding events. So if you recall, in one of our earliest tutorials, we added these key bindings for our punch and our kick. And we're going to expand this out to also include our modifiers. So I'm going to say player input component. I'm going to bind our action to our light attack modifier. And we are going to have to handle our pressed and release state with this particular guy, because we want to be able to turn things off and on. This is going to be our light attack start. I'm just going to copy and paste this, and we're going to change this to released, and we're going to turn this into light attack end. Okay, and then we're going to do the same thing for our strong attacks. There we go. So let's go ahead and now implement these methods in our player character. So going back to our header file, somewhere around our attack start and attack end, I'm going to add these new 4 methods. Light attack start, light attack end. These are strong attacks, as well as our strong attack end. Okay, so we have these definitions. We have our attack strength enum. We also need a couple of booleans to basically flip between these 2 modes. And you'll see in just a second why we use those guys. So I'm going to go to our private section, and I'm going to add 2 new booleans. One is attack light, bool is attack strong. And we also need to introduce our attack strength enum, as we need to keep track of this value as we perform our various operations. Okay, so I think this is enough for our header definition. Now let's flip over to our implementation and start fleshing out these additional methods. So I'm just going to go right around punch attack. We're going to say a props vector light attack start, light attack end, strong attack start, and the last one. And there's a strong attack end. Okay, so what we're going to do here is simply set our booleans to either true or false. Depending on which modifier key we're pressing. So again, pretty straightforward. Nothing overly complicated happening just yet. Now we're going to get a little bit more interesting. So when our buttons are pressed, we're going to flip these values, and now we need to we need to add a little bit more logic into our attack method to be able to determine our current attack type based on these booleans. So I'm just going to flip down to our attack input method, where we pass in the attack type, whether it's a punch or a kick. And then down here, we were constructing our random attack execution. So this is where we're actually determining the the random between 1 to 3 sections. And for the folks who don't remember, let's just put up our animation montage and show you what I mean. So there you go. There's a start 1, start 2, start 3, and we were simply randomly generating that value and playing back a specific hit depending on what value we got. So we're going to change this. Rather than doing a random number generator, we're going to pick the correct attack type based on the attack strength. And we're going to default this guy to nothing. And then what we're going to do is we're going to say switch on our current attack strength. Oops. And what we're going to do is we're going to say, okay, so if our case is light, then what we're going to do is we're going to say our montage section index equals 1. And we're going to break. Then we're going to do our next case where our attack strength equals medium. And our montage section index is going to be 2. And lastly, we're going to do strong, and I'm pretty sure everybody's guessed it by now. This is going to be number 3. Super exciting. And always make sure to include a default case in case things don't go as expected. And we're going to default it to our medium attack of 2 and break. Okay, so there's our montage section, but we're also not iterating over this value. So somewhere right at the top, doesn't matter really where, we're going to do just a little bit of logic. So what we're going to do is we're going to say, hey, if our is attack strong pressed, we're going to default our current attack to medium. Alright, so if our attack strong is pressed, then we're going to say current attack strength equals strong. And we're going to say else if is attack light and not strong, then our current attack strength is going to be light. So we start off at medium, we flip over to strong if we're pressing our left control button, we flip over to light if we're pressing our left shift button, and we're also not pressing in our strong button. Strong always will take precedence. And then over here we pick the correct montage playback. So let's recompile and see what this looks like in the game. Okay, so we're all recompiled. Let's go back to our editor. Let's close down the kick montage, and let's start up our game. So now, whenever I punch, I'm going to default to our medium punch. Whenever I kick, we get our medium kick. If I hold down left shift, I get my alternating punches. There's my light kick. And if I hold down control, I get my strong kick, as well as my strong punch. So now I can nicely alternate between these various moves. Alright, cool. And so far we've done nothing with the physics constraints just yet. But let's get into it now. So to do that, we're going to create a new props class. And we're going to say new class. We're going to use a base class of actor. And under our props directory, rather, we're going to call this guy a physics prop. Yeah, I'll go with the physics prop. Alright, so our physics prop class has been generated. Let's go ahead and start decorating it with some properties that are going to be of value to us. So, first things first, let's bring in the physics constraint component. And as most things, we need to include the appropriate header file. And you're going to find the physics constraint component under the physics engine subfolder within the engine. So physics constraint component.h is what we need to bring in. We're also going to bring in a static mesh component, as well as a skeleton mesh component. Because what we're going to do is we're going to have our sort of static objects attached to physics constraints, as well as we're going to show you how we can hook up a skeleton mesh and then tie the various bone definitions to our physics constraint component. So we're going to say components and skeletal mesh component. All right. So now we're going to bring in our actual properties that work with these three values. So we want a U property. It's going to be visible anywhere. Blooper rerun right. And our category is going to be physics. So this guy's going to be our U physics constraint component. Physics constraint. I'm going to copy this U property definition, and now we're going to bring in our static mesh component. And this is going to be our base mesh. This is going to be the thing that our physics constraint component is attached to. And this is going to be a static mesh. It's not going to move. And then we're going to attach movable meshes to it, which will actually showcase the various interactions we're trying to do. So I'm going to create a new static mesh component, and this is going to be our movable mesh. And then lastly, I'm going to bring in our skeletal mesh. movable skeletal mesh. Okay, so there are our 4 properties, and we're basically going to mix and match these for some interesting results. So let's go into our physics props CPP file and instantiate these guys. Let's just go down here and say root component equals default subobject. And this is just going to be a scene component similar to our destructible prop. And we're going to call this guy just the scene component. And now we can create our various meshes. So let's start off with our base mesh, because this guy really isn't going to be doing too much. So there's our static mesh component. It's going to be our base mesh. And he's just going to be attached to the root component. There's our root component. Now, let's create our movable mesh. Oops. Movable mesh. Create default subobject. And there's our definition. Now, this guy is also going to be attached to our root component. And he's also going to have physics enabled by default. And he's also going to have our custom collision profile of enemy. Oops. Okay, so there's our movable mesh, and now we're going to do our movable skeletal mesh. Very similar. Actually, you know what? For sake of expediency, we're just going to make these guys the same. And use skeletal mesh component. Cool. 2 meshes, 1 skeleton, and lastly we need to also create our physics constrained object. And there's our physics constraint, and we're just going to attach this guy to our root component as well. And there we go. So this is kind of going to be the majority of our C++ code for this particular prop. And I'll show you in just a second why that is. You can go ahead and configure the majority of these physical constraint definitions through code, just as much as you can do through the blueprint. But since you're going to be manipulating these values right up until you're happy with them, you don't necessarily want to commit and go through the workflow of either exposing these values through C++ or going back and recompiling every time. It just takes a long time. So I suggest you work in the blueprint right up until you're good to go, and then if you find that these are static definitions that you're going to reuse across multiple objects, then throw them into your C++ code. And just to show you what these things kind of look like is you can end up basically setting the various component definitions and various properties, just through code. You don't necessarily need to do any of this through the blueprint. But again, it's just a workflow thing. If you want to work faster and quicker, I highly recommend going down the blueprint route. So for example, set constraint components, I can pass in let's get the method signature here again. I can pass in my, base mesh, a particular bone name for it. I can pass in my skeletal mesh as the second one, and all of a sudden I have them attached. I can also set my various constraint references. I can set my various angular drive, my swing limits, my twist limits, my velocity, all this stuff that we're going to look at in just a second in the blueprint. So, you guys can go about it both ways. I'm going to stick to the blueprint for now, so let's recompile and take a look. Okay, so with our project recompiled, let's go ahead and in our props folder create a new blueprint that's going to represent our physics prop. So I'm just going to pick our parent class based off our physics prop definition, and I'm going to call this blueprint physics spring static. So what we're going to do is we're going to use these newly defined properties to essentially create a little punching bag that springs back and forth as we interact with it. So for our base mesh, I'm simply going to use a cube, and I'm just going to scale it down to something a little bit more manageable. This is going to be the base of our prop, and let's give it a grass texture just for fun. And then we're going to work on our movable mesh. So our movable mesh is going to be a capsule. We've got a narrow capsule, we've got a wide capsule, we've got all kinds of different things we can mess around with. Actually, you know what? We'll use the narrow one. It's a little bit cleaner. There we go. And also let's give this guy a texture. So what's a good texture for this guy? You know, we'll go with chrome. We'll make it nice and shiny. Okay, so there's our chrome punching bag. We have our base. And then lastly, we've got this little guy here. So this is our physical constraint. And you'll notice right off the bat, the gizmo has this sphere definition and this sort of green circle in the middle of it. And what these things really represent, on the right-hand side, if you take a look, are the angular limits of our physical constraints. So we have our swing motions, and then we have our twist motion. And that means right now, if everything was working correctly, and we had this guy associated with our base, the physical constraint would allow us to basically, on this pivot point, rotate our punching bag in any direction, because we don't have any limits set. So it can go, you know, sort of omnidirectional. And let me show you what that really looks like. So in order to associate these two objects together, as you saw in our C++ code, we have this set constraints property. And again, you can do this through code, but it's a little bit easier just to manage it through the blueprint. So for the first component, I'm going to set our base mesh, and you'll notice it highlights it in red, which means, yep, physical constraint has one thing attached to it. And the second thing we're going to do is our movable mesh. And again, it adds a little outline around the object showcasing that they are now hooked up together. Simulation isn't going to do anything just because they're not really positioned to move. But if we now take this blueprint, drag it into our level, actually no, let's just play it. So there it is. And if I hit it, you see it rotates and moves around based on that pivot point we defined. And you have physics. I mean, it's kind of as simple as that. But now if you want to make something fun out of this, this is where all the tweaking and sort of the exciting bits come into play. So let's go back to our blueprint, and we don't want this to go in all the different directions. We just want it to go back and forth on one of the axes. So what we're going to do is we're going to modify our swing motions to be limited. So if we take off all of these guys, if we lock them in, this is going to keep everything static. So if you were to interact now with this component, you see it doesn't move. It has no angular movement. It's got no linear movement. That means it can't go up and down or left and right. So now we can start experimenting with these individual swings. And if you notice, if I just turn on swing 2 motion, we get a 45-degree angle, which is defined by the limit of how it can swing. But because we don't want it to go from 45 degrees into the ground, we actually want to kind of go 45 degrees along the Z, or with the Z facing upwards. What we want to do is we're going to rotate this gizmo 90 degrees to the left. So like any other component, we just drag it and rotate it by 90 degrees. And now we have that 45 degree swing in either direction going up from our z-axis. So now if we were to play this, oops, you'll notice our little silver bullet there kind of goes back and forth if we hit it. So let's make it just a little bit bigger in the editor so we can punch it and kick it and generally start messing around with it. So that seems big enough. Good for punching. And bam! Now we can just hit it. But we're not getting that springiness back. We're getting motion, we're limited to a single axis, our physicality is working okay, but we're not getting that little that spring back. So, going back to our blueprint, a little bit lower in the physical constraint settings, we have the angular motor. And the angular motor is the thing that actually controls the springiness of this 45 degree angle motion. So there's the slurp option, but we're interested in the twist and swing configuration. So if we change your angular drive motor to twist and swing, it now takes over the control of our swing and twist motions, fairly straightforward. And then you have the option of saying, okay, do I want to work on twist or do I just want to work on swing? And in our case, since we're only using this swing motion, we're going to say, yep, only work on swing. So there's our swing. And you have the strength as well as the target velocity you can start messing around with. And you'll notice at 50 units, not a large difference. There's a little bit of a springiness back, but it's not as sort of as punchy as we want it to be. It's a little bit weak from a spring definition. So you can go ahead and now adjust this value. So let's just bump it up to, let's say, 100. We're doubling up. And now the springiness is just a little bit more accentuated, a little bit stronger. So now we almost have our punching bag working really well. But you can, again, go ahead and mess around with these values. So if we, for example, increase the strength of our velocity, you'll notice now it's a little bit harder to move. It's starting to get just a little bit more stiff in its behavior. And again, we could even bump up this value to, let's say, 500. And now it's going to be really kind of springy. You see, if I run up against it, I need to apply a fair bit of force to actually get it to move. And if we kick it, it's now nice and bouncy. It comes right back. So cool. We just created a little physically constrained prop for us to interact with. So let's go ahead and create another one. Now that we have this basis in place. And let me show you how quickly now we can start turning this back and forth punching bag to one that, let's say, hangs from the ceiling and has way more articulation, a little bit more movement. So let's see how that works. So I'm just going to right click on our physics spring static blueprint. I'm going to duplicate it. And I'm going to change spring to be hanging. And we'll also work with our static object. So let's pop up on this blueprint. Let's take a look at our base mesh. Okay, so since we're going to have this punching bag now hang kind of from a ceiling position, I'm going to change the base to be up top. And again, it doesn't really matter if it's up here, because our constraint is really being driven by the physical constraint definition, not necessarily the orientation of this object. But again, once you start playing around with this, you'll notice sort of the power of combining these various objects together to accomplish what you're looking for. Now you'll notice, again, because we duplicated our blueprint, the orientation is actually facing upwards. We need to rotate this around the other way. So if I just change the orientation and then now rotate it, downwards by 90 degrees, I now have it positioned a little bit more correctly. It looks a little bit nicer. And I'm going to pop it up so it looks like it's articulating from right at the top of our ceiling component, even though it's grass textured. And we don't want it to swing just back and forth. We want it to swing this way as well as in the other direction. Again, like a punching bag would swing. So what we're going to do is we're going to set another limit on the swing, and you'll notice it creates this nice little cone, which means everything can move within this 45-degree stretch. But that's not a lot of movement. And let's see actually what this looks like. So I'm just going to save our blueprint and then drag it into the level. Get a little bit higher, and let's just scale it up a bit. Okay, so there's our thing, and you'll notice because we copied all the springiness, it springs back and forth. Actually, you know what? Let's make it a little bit lower. Yeah, so it springs back and forth now in both directions. But we don't want it to spring. We want it to now just kind of hang loose and do its thing from the ceiling like a real punching bag. So to do that, we're going to go back to our blueprint. We're going to pop open the physics constraint component, and we're going to remove all of our angular drive definitions. So we'll just leave those, empty. And we're also going to adjust the angle so it's a little bit wider. So we'll do 85 degrees in both motions. So now we should be able to get the punching bag going all the way up to the ceiling and back the other way. And it should clip on top of the base, which will cause it to bounce back down. So let's move it around, and there it goes. It's nicely swinging. And if I hit it, you see it goes all the way up to the base and then stops. You can actually kind of jam it up if you get the character underneath it, because it has all that lovely swinging motion. So yeah, there you go. Look at that. We created a punching bag, and whatever we want to call this little thing, in no time at all. So what else can we do with this, with these physical constraints? I mean, there's a bunch of different options, and you can, sort of daisy chain them together for various effects. And we'll get into, how to attach our destructible objects to this too, and all kinds of other stuff. But let's now take a look at how we can turn these two props from our static meshes to actually use a skeleton mesh, so we can get some punch test dummies going. And again, I'm not going to kind of reinvent the wheel too much. So what we're going to do is we're going to take this physics spring static, duplicate it again, and we're just going to rename it to be physics spring skeletal. As I'm sure you can figure out, all we're going to do is we're going to take our movable mesh, get rid of it, and we're going to add in a skeletal mesh. So I'm going to pick our mannequin component and position him just a little bit above our base, somewhere here. And now if I go back to my physical constraint, he's going to go from side to side, the way we have this defined. So let's rotate our constraint so he goes... Actually, you know what? We don't need to do that. We can simply set the limit on the other swing motion. So he's going to swing back and forth, but you'll notice in our constraint definition, we're still attached to a movable mesh. So let's attach ourselves to the movable skeletal mesh. And you'll notice what's interesting about the skeletal mesh is by default, the physical constraint attaches itself to the root or the primary bone for our skeleton, but we can reposition that. So let's take a real quick look at our mannequin and sort of how the bone definitions plays in line with our physical constraint. So if we pop open our mannequin and we go to the skeleton, you'll notice we have all these lovely bones defined. Spine 3, spine 2, spine 1, but we are being attached right at the pelvis because that's the root definition for it. So let's go ahead and attach him, let's say at spine 2, and see what that looks like. So if you go back to our physical constraint on our new blueprint, you'll notice these two additional properties here for the constraint bone. So it's pretty easy. Associate component number with bone number, and we're going to say spine 02. And you'll notice the blue box that ties us down to the constraint moves up accordingly. If, for example, we said calf L, it attaches it to the leg bone. But we want to kind of do it at the chest level. So when we punch him, he will kind of swing back and forth, back and forth. Now, just by default, we already have simulate physics turned on this skeleton, so he should just kind of work, unless we don't put him in the actual level. So there's our little guy. And look at that. Falls right over. But he's being, sort of attached to our spring. The problem is, he's too damn heavy. So because of his weight distribution, he's actually able to bend the spring component a little bit more than, for example, this guy here. He's a little bit less solid than our mannequin. But that's okay, we can fix that. So if we go back to our physical constraint, what we're going to do is similar to our other punching bag. We're going to go down to our our angular motor section, and we're just going to start messing around with some of these values. So for example, we can bump this guy up by a couple of additional zeros, and all of a sudden the strength that's being applied to the springiness is preventing him from going too far. We're actually able to compensate for the weight of the mannequin. And, if we punch him, he kind of flips back and forth, nicely flowing back. The ragdoll effect is simply because we turn on physics. And that's to be expected. But there you go. There's a very quick punch test dummy. So we got this guy floating around, and we can kind of we can beat him up a little bit in all kinds of different ways. And it's going to be helpful when we're prototyping some of our superpowers and special moves and combos and all this stuff. It's going to make it fun for us to actually practice on these dummies. But we have our spring dummy. Let's see if we can get a hanging dummy that kind of looks like this punching bag. So how do we do that? Well, again, let's be lazy developers and let's reuse as much as we can. So we're going to duplicate our hanging blueprint, and we're going to rename it to physics hanging skeleton. And we're going to do the same thing we did with our other one. We're going to take our movable mesh and get rid of it. We're going to raise this piece up just a little bit. And then for our skeletal mesh, we're going to pick our mannequin again. But in this case, you know, let's make him hang. So I'm just going to rotate him around. So he's upside down. We're going to gently lift him up. And I'll actually make this go a little bit higher. And then we're going to say, assign our physical constraint to our skeletal mesh. And in this case, I'm going to attach it to, well, calf right. Let's see how that works. So the other thing we want to check is our constraints. So it's going to move in all of our directions. We don't have any of our angular motors defined. So we are kind of done with this. Let's go ahead and compile it, drag it into our level, and see what this guy looks like. I'm just going to pop him up here so he's kind of at the similar height as the other one. We want to have a nice sort of chest area that we can punch and kick. There you go. Look at that. There is our hanging punch test dummy. He's attached to the calf. He's got full sort of range of motion based on our two constraints there. Identical to this guy here, but just using a skeletal mesh. And again, you know, we can punch it, we can run into it, and it will do all this wonderful stuff. Come on, there we go. Let's see if we can get him to slow down. Oh, it keeps missing it. But yeah, there you go, guys. That is how very quickly we can create a bunch of physics-based components. I mean, they're not super complicated, but they do start offering you a lot of flexibility, and you can start messing around with these various configurations and settings to accomplish all kinds of stuff. You know, ramps, doors, and all kinds of swinging bits, lanterns, and chandeliers, and things like that. Pretty neat, guys. So, as usual, I'll be posting all the code and the sample project for this exercise on my GitHub page, and I hope to see you guys next time when we start exploring our player character a little bit more and just make him a little bit more interesting, so we prep our way for actually fighting some of these bad boys. Look at him go. And you can also get some weird and interesting sort of fun effects if you start hanging him by the arm and the head, and you can even, you know, attach multiple physical constraints to different body parts, and you know, sky's the limit, you guys. So thank you for tuning in, and hope to see you next time.